So up till now, basically everything we focused on has been dealing with point charges. So, sort of infinitesimally tiny particles of charge. But of course, that's not how we interact with charge on a day-to-day basis. Instead, what we end up dealing with is we end up dealing with two different types of materials. The first of which are conductors. And conductors are basically a material where the charges can move freely in response to an electric field. Most conductors are metals. And certainly sort of almost all the conductors that we deal with on kind of a day-to-day basis are metals. The other type of material you can have is an insulator. And this is a situation where we don't have charges that can move freely in response to an electric field. Instead, the charges are bound inside the structure of the material. So, plastic, wood, glass, rubber, these are all relatively good insulators. And so the picture that sort of goes with this is that let's say I happen to have this charged rod. And so what it does is it's got some positive charge on the end of it. A conductor basically has what are known as free electrons. And those free electrons are effectively able to sort of skip from atom to atom within the structure of the metal so that they can come over, right? They sort of feel the attractive presence of this positively charged rod. And so you have free electrons from over here that come over, which gives you an excess amount of negative charge over here and an absence of negative charge over here. So you end up with a negatively charged side of the conductor where all these free electrons have gathered in response to the positive rod, and then a positive side of the conductor where all the free electrons have left. With an insulator, well, sort of things respond to the electric field being generated by our positive rod, but they can't get away. So because in an insulator those electrons are much more tightly bound in the structure of the atoms, you will see what's known as polarization. Right? This is you've polarized the atom so that there's a negative side and a positive side of the atom, but those electrons can't get away from the atom that they're with and end up coming over to this side of the conductor. So we'll deal with this scenario when we're talking about dielectrics. Right? But this is a situation where you can polarize an insulator, but you can't sort of get a huge chunk of negative charge like you do with a conductor. So given that difference, there are actually two ways that I can charge a conductor precisely because it's got these free electrons. So one thing I can do is charge it by conduction, which basically is just a function of charging it by contact. So what that means is I've got, again, I bring my positive rod close to my conductor. So then the free electrons come over in response to the positive rod. So I have a negative side and a positive side. And then I'll actually put them into contact, basically just touch the rod to the sphere. And so some of those free electrons will basically transfer over to the rod. And so what I'll be left with is now less electrons than what I should have, so that I've charged by conduction. I started with a positive rod, and I've given some of that positive charge to my conductor. The other option I've got is charge by induction. Again, notice I'm going to start with basically when this rod is far away, I've just got a neutral conductor. So I've got an even number of positive and negative charges. They're not separated in any way. But when I bring my positive rod close, again, I get my charge separation, so I get my free electrons to come over here. I'm left with a positive side of the rod where all the free electrons have left. But instead of touching the rod to the conductor, this time what I'm going to do is I'm going to ground the conductor. So this symbol, we'll see it quite a bit throughout the semester, where I have sort of a series of lines that each one's shorter than the next. This is the symbol for a ground. And in grounding the conductor, basically what I'm doing is I'm saying now there's a pathway to the ground, and the ground has as many sort of free electrons as I need, so that what I can do then is drag additional electrons up that ground so that I have more electrons than what I started with on my conductor. So you notice that charge by conduction gets you the same charge you started with. Charge by induction gets you the opposite charge because you're using the ground as this reservoir to either pull electrons up from or dump electrons down to, depending on whether this rod is positively or negatively charged. So these are the two ways that we can charge conductors. And again, basically both of them are letting these free electrons respond to an electric field however they need to.